Let us have another example of t-test of dependent means. At a recent PGA tournament, the Honda Classic at Palm Beaches Gardens, Florida, the following scores were posted for 8 randomly selected golfers for 2 consecutive days. Here you go. At alpha equals 0.05, is there evidence of a difference in the mean scores for the 2 days? So pause the video and try to answer this problem. So let us see if this problem is actually for the test of dependent means. Dependent means. Alright. So remember, the condition for us to have a t-test of dependent means would be there is only one sample, but we actually have two data sets. There we go. So let's see our data to see if we will follow this condition. So here we go. Let's just move a little bit. Alright. So in the problem, it says, oops, sorry about there. So the following scores were posted for 8 randomly selected golfers. So we have our 8 golfers here. And these 8 golfers compose already of our one sample. So we already have just one sample. And we have two data sets. The scores of the golfers for Thursday and the scores of golfers for Friday. So again, we have one data set and we have one sample rather, but we have two related data sets as they came from the same person in the sample. So this problem is an example of the test of dependent means. So this is followed. So now we can go to our different steps in hypothesis testing. So as always, our step 1 is always to have HO and HA depending on our claim. So what is the claim here? At alpha equals 0.05, is there evidence of a difference in the mean scores? So that means the mean of Thursday should be different or not equal to the mean of Friday. So since this is not equal, inequality, therefore it shall be for our HA. So we have the mean of Thursday is not equal to the mean of Friday. And since it did not say that whether it's greater than or less than, it shows that it's not equal. And because of that, this will be a two-tail test. And at the same time, our null hypothesis would be that the mean for Thursday is equal to the mean of Friday. So there you go. So now that we have our step 1, it's time now to do our steps 2 and 3. So to do that, we shall now go to our data ribbon. There you go. Data analysis here. And again, let's just take a closer look at that. We will select here t-test paired 2 sample for means. We click OK. And again, we need to input our variable 1 and 2. So to input our variable 1, since we selected Thursday first, so we will select Thursday as our variable 1 here. Oh, and by the way, in the problem, it did not actually say which one to choose first. So we will just choose naturally the first given data set. And then for variable 2, it will be, for variable 1, let's just go back. We only have to select until 70. There you go. Variable 2, select until here. There you go. And then hypothesize mean difference. There's none. Labels are checked. Alpha equals 0.05. Output, I'll just place it here. And then when everything is okay, we click OK. There we go. Let's just, oh, maybe we can move the table a little bit here, not to be covered by our scribble. Adjusting, there you go. Now we can do our step 4. So for step 4, let's see on what we would need to check. Since this is not equal to, it has to be a two-tail test. Therefore, we will look at the p-value for two-tail. So let's zoom in on that. There you go. This is the mean, the variances, and all that, and two-tail. So we have 0.0466 or 0.05. So here, but I will take 0.047 and I will explain that in a while. So the mean that I will get would, oops, sorry about that, mean or p-value rather would be 0.047. Now why did I not take the mean of 0.05? Because it will just be equal and it will be difficult for us to compare. Remember that our rule is that if the p is smaller than alpha, since here it's actually smaller, but if we round off it becomes equal, so let's just round it off rather in the way that it will reveal its true number in a way. So that's why this is a smaller number. And of course, compared to 0.05, we have already mentioned that 0.047 is smaller than 0.05. So therefore, we shall reject our null hypothesis. Therefore, our conclusion would be there is sufficient evidence, sufficient evidence to reject HO. Therefore, is there evidence of a difference in the mean scores? The answer is yes. There is evidence of a difference in the mean scores.